Hey, Nate Mullins here, and I have another video tutorial here, and this one may completely blow you away. Hopefully you can understand. I'm going to try to explain it as well as possible, but there are four formulas in which I derived the divisibility rules for any number ending in 1, 3, 7, or 9. Now, we learned the first, 11, then when we did composite divisibility rules, that was like 12, where we check for divisibility by 3 and 4. 15, you check for divisibility by 3 and 5, and so forth. It went up to 99, that's 9 and 11. But we're going to look at numbers ending in 1, 3, 7, or 9. And I'm going to keep doing these until we get all the divisibility rules for all numbers. Every number has a divisibility rule. Every number does. And of course, if a number ends in 2, the only prime numbers, and these are going to include a lot of prime numbers, since prime numbers past 10 only end in 1, 3, 7, or 9. The only exceptions, of course, are 2 and 5. But remember, I said past 10, so and it happens to be at 13, 11, 13, 17, and 19 are all prime. Now that doesn't quite have to do with the divisibility rules, but you're going to see a lot of divisibility rules for prime numbers, and so your prime numbers after 10 will always end in this. It can't end in 5, since that's divisible by 5, and it can't be 0, 2, 4, 6, or 8, because that'll be divisible by 2. So let's cut to the chase here and briefly recall the stem and leaf concept. Pretty simple. The leaf is simply the ones digit, and the stem is that number that's formed by the remaining digits. So for example, 57, 7 is the leaf and 5 is the stem. 189, 9 is the leaf, 18 is the stem. 27,429, 9 is the leaf, and 2,742 would be your stem. And remember the steps, and this was in our divisibility by 7. In a generic sense, in every case, you're going to break the stem and leaf. You're always going to break the stem and leaf into two separate numbers. So we're checking 231, see if it's divisible by 7. This is, for example, just recalling that. Have an earlier tutorial on divisibility by 7, 8, and 11 as well. So you break it apart into 23 and 1. So that was our first step. You break up the stem and leaf. And then you do something to that. You take the product, and it depends on the functions that really should read. Next slide. I reversed these the last second here. And the leaf, L. So you multiply the leaf, you break the leaf off, and then you multiply by something. And then you are going to add or subtract that number from your stem. So for instance, testing 231, okay, we multiply that leaf by 2. We broke it apart here, and so it broke into 23 and 1. So now we're going to multiply the 1 by 2, which gives you 2. 23 minus 2 down here gives you 21, a multiple of 7, so therefore 231 is divisible by 7. And so that's the rule, of course. If you eventually reach an identifiable multiple of, that's a little tongue twister there, identifiable multiple of that number. For instance, if you're checking for divisibility by 17, then if you get a multiple of 17, like 17, 34, 51, and so forth. You can also get 0, and it can also be negative. So you might, if you're testing for, like in the case of 7, you may actually get minus 7 or even minus 14. And you can only go to minus 14 actually with 7. But you may get a negative number as long as it's still, for 17, for instance, if you get minus 34, minus 34 is just negative 2 times 17, so negative multiples will work as well. And of course, if you get 0, that also passes the test, so to speak. And a side note here, you may have to repeat for a really big number, and depending on the numbers you're using, you may have to repeat this until you get a clear, that's what I meant by identifiable, multiple of that number, or 0, or a negative multiple of it. So the general derivation, these are the formulas that I was talking about. Now, an important distinction to make here is that our general formula is stem, and then you break that apart, and then you multiply the leaf by something. Now remember, I said you might be adding that number. This could be negative, so you might be subtracting as well. And in fact, in 2 cases you add, in 2 cases you subtract. So this is the general formula, and this is the stem and leaf of the number in which you're testing divisibility for. So for instance, 79, you'd use this. In fact, we can derive that right now. See down here for 9, s plus 1. So 79, the stem would be 7. So s is the stem. 7 plus 1 would be 8. So you plug that into here, and you get s plus 8l. So for checking divisibility by 79, and you'll see that in a few slides here, s plus 8l. So you'd break the stem and leaf of the original number apart. This is not to be confused with the stem and leaf of 79. This is the generic formula for any number in which you're testing 79 for, and it'll be in the case of 79, it will be 8. So your stem, you break off the leaf, you add 8 times the leaf to that, and you might have to repeat this process a few more times. So for 1, x is simply negative s. So the formula is s minus, and again, because you're performing an operation here that breaks into 2 numbers, breaks the stem and then the leaf off, that's why I'm not factoring out an s here, because algebraically, well, it would look like that's what you should do. However, you can't do that because, again, we're forming a different number, so that sort of doesn't apply. Otherwise, you could factor out an s and say s times parentheses 1 minus l. But that's our formula, and that's actually pretty easy. For 3, it's a lot more complicated. The pattern is this: 3s plus 1. So the formula is s plus, and this is substituted in for x, 3s plus 1 times l. For 7, x is negative 3s plus 2, or you could, if you didn't distribute it, or if you distribute the negative sign, it would just be minus 3s minus 2. But we'll just bunch that all together, put it in parentheses, and notice notice the negative sign here. You subtract, and for 9, like I said, s plus 1 is your x, plug it in here, and that's what you do to the leaf. So generally speaking, you break the stem and leaf off, you do something to the leaf, and this is what you do to it, based on whether your number of interest ends in 1, 3, 7, or 9. So ending in 1, we have that formula which I derived, s minus sl. So 11, now this, okay, 11 is simply s minus l, and recall that from the earlier video that we did in 11, because the stem is 1, so it's just s minus 1 times l, s minus l. 21, well, the stem is 2, so s minus 2l. And 21 you can also check for divisibility by 3 and 7, and by the way, 7 happens to have this same, not coincidentally, have this same formula. And 21 is that's the other reason. 2 plus 1 is 3, so therefore 21 is divisible by 3, and that's sort of why that works. But s minus 2l, that was the same rule that we had for 7, and you'll see that here in just a minute. 31, s minus 3l, and so on. Now for 51, I would recommend using this. You can do it using 3 and 17, but this, I think the rule for 1 and 9, as you saw in that last slide, our rules for 1 and 9 were much simpler than the rules for 3 and 7, because you have to add something in the middle here, and you can end up with some pretty large numbers that you're multiplying and dividing by, or, well, you're multiplying by, and then you have to deal with subtracting or adding that from the rest of the number. So here are the general formulas for anything. So it's the stem minus 6 times the leaf, 6 times the 1's digit for 61, 71, 81, and so forth. These are the general formulas. So if you want to write these slides down, jot these down, put it in with all the rest of your notes on the divisibility rules, feel free. And similar thing with 91 here to 51. You can check for divisibility by 7 and 13, but that actually doesn't make sense because you have to undergo both processes here, checking 7 and 13, when you can do it all in one step here using the 1 rule that was derived, s minus 9 times the 1's digit. So again, this is when you're breaking apart a number, and we'll show you an example here. 101 also would be s minus 10l. Just throw that in for good measure. So ending in 3. So here's how you derive this. If you can imagine a 0 here in front of the 3, that's the stem, and well, 0s plus 1 is just 1, and that's just s plus l. Well, that's the same thing as adding the digits in the number, which is the divisibility rule for 3. Check and see if those add up to 3 or a multiple of 3. 13, s plus 4l. The stem here is 1, so the rule that is derived for 13, s plus 4l, comes from this formula. You plug 1 in for the stem, that's 3, plus 1 is 4, so that's where your 4 comes from. Likewise, 23, s plus 7l, so you would break your original number up, and then you would take 7 times the 1's digit and add it to the rest of the number. So 23, you plug in the stem, the value of the stem, which is 2. 2 times 3 is 6, plus 1 is 7. So that's where these numbers are coming from, this formula up here. For 33, you can do s plus 10l, multiplying by 10 is easy, or you can check for divisibility by 3 and 11. Either method will work. For 43, s plus 13 times the leaf, or the 1's digit. L is always the 1's digit, just remember that. 53, it's 16, and so forth. And 63, you have a number of options you can check. You can do s plus 19l. It might actually be easier to use 7 and 9, or you can use 3 and 21. It really doesn't matter because 21 and 7 actually, remember, had that same rule, s minus 2l. And the rules for 73, 83, and 93. And then 93, again, it would probably be easier to do 3 and 31. Either method will work, s plus 28l, but you can also check for divisibility by 3 and 31, and 31 was s minus 3l. A little easier to subtract 3 times a number than to have to do 28 times a number. That's where I'm getting at here. With it might be easier to do 3 and 31. So now we move on to 7, and this is our formula, s, and then this is what you do to the leaf. This is the operation you perform on the leaf here, the 1's digit. To break the number up in s, and then you subtract a certain amount times the 1's digit. Notice the negative sign here. And 7 was a special case of that because, again, if you can imagine a 0 here as the stem, well, 3 times 0 is 0, plus 2 is 2, but you're subtracting it, so 7 minus 2l, and recall that from the earlier video. 7 is s minus 2l. 17. The stem of 17 is 1. So you plug that into this formula for what you're doing with the leaf, and 3 times 1 3 plus 2 is 5, and so minus 5L. Lo and behold, there it is. And then you can see the pattern for all these. They increase by 3 because that factor of 3, and then of course minus 2 as well. You're distributing the negative sign, so it's really minus. So anyway, 27, the stem is 2, so 3 times 2 is 6 plus 2 is 8, but that's being subtracted. So you subtract 8 times the ones digit from the rest of the number, whatever number you're testing divisibility by 27 for. And then 37, 47, 57, you can do this, or it might actually be easier to do 3 and 19. And I'll show you the 9s here in just a second. 67, that's prime. There's no other way. This is actually not too hard because it's 20 at least. You get a nice round number there. Multiple of 10. S minus 20L. 77, again, probably be easier to check 7 and 11 because they're a bit easier than this minus 23L business. 87, again, you can use this, or you can use 3 and 29, just like 57 might be easier. For 97, that's prime, you have to use S minus 29L. So finally, numbers ending in 9. And that one's fairly straightforward. It's just S plus the stem plus 1 times the leaf. So the divisibility rule for 9, if you can imagine a 0 here as the stem, well, 0 plus 1 is 0, and just like 3, it was just S plus 1 times L, or S plus L. And again, that's like 3, that's the same as adding the digits, except that here the digits have to add to a multiple of 9. For 19, the stem is 1, so to get the formula for 19, you plug 1 in here, and that's S plus 2L. Bingo. For 29, and it's pretty straightforward, 3L, 2 plus 1 is 3. And for 39, you can do S plus 4L, or you can check for divisibility by 3 and 13. Whatever's easier for you. 13, as I recall, it was S minus 4L. 49, S plus 5L, and so on. 69, you have the option of S plus 7L, or you can check for divisibility by 3 and 23. 79, 89, and 99. Again, 99, you can do S plus 10L, because that's not hard, multiplying by 10, and then adding that on to the rest of the number. Or you can check for divisibility by 9 and 11. A couple options there. So now that we have those figured out, here's some other numbers. Divisible 26, for instance, you can go back over the slide to review all of these numbers here, but for 26, it has to be divisible by 2 and 13. 34, 2 and 17. 38, 2 and 19. 39, 3 and 13. Again, you can also use the other formula for 9. 46, divisible by 2 and 23. For 51, 3 and 17. Or, might be easier to use the 1 rule. For 52, 4 suits and a deck of cards, and 13 cards in each suit. Gives you 52, 4 and 13. 54, 2 and 27. 57, 3 and 19. Or you can use that formula for 7. 58, 2 and 29. 62, 2 and 31. 63, you can use the rule for 3, or you can check for divisibility by 3 and 21, or 7 and 9. Either one will work. 65, now that would be divisible by 5 and 13. For 68, 4 and 17, and there's plenty more. 69, 3 and 23, or, as I suggested, using the 9 rule. For 74, it would be 2 and 37, 76, 4 and 19, 78, 2 and 39, or you can do 2, 3, and 13, which would be the same as 6 and 13. 82, 2 and 41, 85, 5 and 17, 86, 2 and 43, 87, 3 and 29. Now 91, again, you probably want to use that rule for 1 and not check for 7 and 13 because that's harder. It involves like twice the amount of work. 92, check for divisibility by 4 and 23. 93, use 3 and 31. 94, 2 and 47. 95, 5 and 19. And finally 98, 2 and 49. So a couple of examples based on 1. So 71, remember the general formula to derive the divisibility for 71, because it ends in a 1, we're going to use this formula. And so S minus 7L, it's just SL. So S minus 7L. So how do we apply that here? Well, we take the stem. So 2,343 is divisible by 71. We're going to prove that right here. 2,343 breaks apart into 234 and 3. Now, we're going to take that 3 and multiply it by 7, and then subtract it from this. So first, 3 times 7 is 21, and then 234 minus 21, 213. And 213, not too hard to see, is a multiple of 71. It's just 71 times 3. You can work that out, and you get 213. It happens to be 71 times 33. So we just proved that 2,343 is indeed divisible by 71. Now, here's an application of 3 and 31, and recall 31 was S minus 3L, since the stem is 3. So you check for divisibility 3,906, check for divisibility by 3, which it is. 3 plus 9 plus 0 plus 6 gives you 18, that's divisible by 3, so check there. We're good, and now let's check for divisibility by 31. So we're going to use this formula here. We're going to break 3,906 into the stem and leaf. So here's your stem, 390, and then your leaf, 6. You're going to multiply it by 3 to give you 18, and subtract that from 390, and that gives you 372. Let's repeat that, just so we can get a clearer multiple of 31. 372, then, you break it apart into 37 and 2. Again, S minus 3L, so you're multiplying the leaf here, 2, by 3, which gives you 6, and you're subtracting that from 37. 37 minus 6, guess what? That's 31. Of course, a multiple of 31. So 3,906 happens to be 93 times 42. So now let's move on to a couple of examples based on 3, in which we use 3s plus 1. That's the operation that we're doing on the leaf. Before we add it, notice we're adding this time, not subtracting. For 1 and 3, 1 you subtract, and 7 you subtract. For 3 and 9 you add. But anyway, 4,108 divisible by 52. So we have to check for divisibility by 4 and 13. So 13, as you recall, was S plus 4L, because when you plug that stem of 13 here, 1, you get 4L. So the ending in 08, you look at the last two digits for divisibility by 4. Obviously 8 is divisible by 4, and so we're good there. So now let's check for divisibility by 13. 4,108 breaks down into 410 and 8. So you multiply 8 by 4, gives you 32, and remember, you're adding 32 back to this number, 410. And that gives you, when you add, 442. So let's repeat this until we get a clear multiple of 13. 442, you break into 44 and 2, and again, you're taking 2 times 4, that's 8. So now 42 plus 8, guess what? That gives us 52, which definitely tells you that it's divisible by 52. And of course it's divisible by 14, it's 4 times 13. 52 times 79 is what gives you this number, 4,108. So now let's do 83, a little bit bigger number. 5,478 is divisible by 83. Let's prove that. And remember, if you plug in the stem of 8 to this formula, 8 times 3 is 24, plus 1 is 25. That's where this s plus 25L comes from. So 5,478 breaks apart into 547 and 8. And so you take this 8, and again, remember you're multiplying by 25. 8 times 25 is 200, and then you're adding that. So 200, that makes a nice number to add to 547, gives you 747. Not the plane, but the jet plane, but you know what I'm talking about here. The number 747. And let's repeat that until we get a clear multiple of 83. You know, you could work this out in your calculator and get that. Let's break that down even farther. We can take 74 and 7 from this, and then 7 times 25, 175. You add that to 74, and you get 249, and hopefully you can see there that that's 83 times 3. So that is a multiple of 83. You didn't carry anything over. 3 times 3 is 9. 8 times 3 is 24. So 5,478 is divisible by 83. That happens to be 83 times 66. So now let's move on to 7. Then we'll do 9, and then we'll be done. There's just a few more numbers left after this, and then we'll be done with everything from 1 to 100, or well, 2 to 101. I showed you 101 there. Okay, 7. This is the formula. So we're subtracting this whole thing, 3s plus 2. So the 2,961 is divisible by 47. Let's prove that. And s minus 14l, where does that come from? Well, the stem is 47, so plug that in here. And that's where your 14 comes from, because 3 times 4 is 12, plus 2 is 14. So that's where you get s minus 14l. So now let's break that up. 2,961, you break into 296 and 1, and then you multiply that 1 by 14, and you're subtracting again, just like you did with the 1. So you're subtracting 14 from 296, which gives you 282. And let's repeat that. 282 then breaks apart into 28 and 2. And again, you take this leaf, 2, you multiply it by 14, which gives you 28, and you subtract that from 28, and guess what? You get 0, which is, of course, 47 times 0. So, therefore, 2,961 is divisible by 47, 63 times. Now, let's do a composite rule here. 4 and 17 to check for divisibility by 68. 3,128 is divisible by 68. And the rule for 17, the stem here is 1, so it's just 1 times 3 is 3, plus 2 is 5, so s minus 5l is your divisibility rule for 17. So it's divisible by, it has to be divisible by 4 and 17. 28, ending in 28. Remember, for 4, you look at the last two digits. 28, clearly divisible by 4. 4 times 7. So now let's check for divisibility by 17 using this. 3,128 breaks apart into 312 and 8. So you take the 8, you multiply it by 5, which gives you 40, and then you subtract that 40 from the rest of the number. So 312 minus 40 gives you 272, and let's repeat that. So you can get a clear multiple of 17. 272 then breaks apart into 27 and 2. Again, you take this 2 and you multiply it by 5, you get 10. So you're subtracting 10 from 27, and guess what? That gives you 17. Clearly a multiple of 17, obviously. And that happens to be 68 times 46, and that gives you 3,128. So now finally, the 9s. And that is simply s, and then you take one more than the stem. That's what you're doing to the leaf. You're multiplying it by that, and then you're adding again, just like you did with 3. So 2,128 divisible by 19. And for 19, s plus 2l, because you take this stem of 1, plug it in here, and you get 2, s plus 2l. So let's break this down. 2,128 breaks into 212 and 8. 8 you multiply by 2 and then add it. So 2 times 8, 16, and then you add 16 back to 212. That gives you 228. And let's repeat that. 228 breaks apart into 22 and 8. Again, you multiply 8 by 2, again giving you 16. So you add 22 and 16, that gives you 38. And there you see clearly a multiple of 19, 2 times 19. So therefore, 2,128 is divisible by 19. 19 times 112. Wow, this is like magic, right? One more example for you. 4,002 is divisible by 58. Well, that would be 2 and 29. And the divisibility rule for 29 you can derive using this formula. It's s plus 3l because 2 plus 1 is 3. The stem is 2, so 2 plus 1 there, 3. S plus 3l. First of all, check for divisibility by 2. Well, it's even because it ends in a 2, so it's divisible by 2, passes that test. Check for divisibility by 29. So this is your rule, s plus 3l. So you break 4,002 into 402 and 2. So 2 separate numbers there. You take the 2 and multiply it by 3, and then you add it. So 2 times 3 would give you 6, and so you add that to 400, gives you 406. And let's repeat that. Break the 40 and 6 down into 40 and 6. Take the 6, multiply it by 3, giving you 18, and that you add to 40. That gives you 58, and well, 58 is clearly a multiple of 58. It's also a multiple of 29. So therefore, 4,000, it's 29 times 2. So 4,002 would be 58 times 69. So there are only a few numbers less than 100 left. We've covered 8, but I have another method that's actually even easier, I believe, than the one I presented in a previous tutorial. And the powers of 2 are a real pain because you have to look at a set of digits, and they're very difficult. But I'm going to have something that's going to be a method to the madness here. Speaking of madness, there's a reason why numbers like 64, that's 2 to the 6th power, that's the number of rounds in minus the play-in rounds of the NCAA tournament. Of course, the powers of 2 are great for tournaments, but they're terrible for divisibility rules because everything goes into everything. 16, for instance, you can't use 4, you can't use 2 and 8 because 2 goes into 8. 32, you can't use 4 and 8 because, well, 4 goes into 8, so you don't have that least common denominator. And likewise, 48, you could use 3 and 16, but we haven't learned 16 yet. But I'll show you that. And then 64 is probably the hardest of them all. That's a little bit complex. And then for 96, we'll use 3 and 32, which, again, I'll show you 8, 16, 32, and then 64. And then we can get 48 and 96 from 16. So hopefully you found that interesting and educational, and in the next tutorial we'll go over these numbers, and then bam, we'll have them all. Thanks for watching.